Good morning. Today we are going to start new chapter in physics. The first lesson we have is measurement. So under this topic we are going to discuss in detail about what is measurement and physical quantities. Under physical quantities, fundamental quantities and derived quantities, and SI system of units and fundamental units. Under fundamental units we are going to discuss in detail about length, mass, time and temperature, then rules and conventions for writing SI units and their symbols, and finally measuring mass and its accuracy. So first, you all know measurement is important in our daily life because it gives answer for certain questions like how heavy the object is, how far we have traveled, how much distance we have covered in the basis of measurement. So without measurements we cannot specify the distance covered or the weight of the object or amount of the substance. So the definition of measurement is, it is defined as the determination of the size or magnitude of the quantity. Size or magnitude. So magnitude means the amount. So it specifies the amount of a substance. Next, we are going to see what is meant by physical quantity. Physical quantity is a quantity that can be measured. So which we are able to measure, we call it as physical quantity, and it is of two, and first one is a fundamental quantity and the next one is derived quantity. So we are going to see first fundamental quantity. So you can see the quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities. On the right side you can see quantities which can be expressed in terms of fundamental quantities are called derived quantities. Moving on to unit. So what is a unit? A unit is a standard quantity with which unknown quantities are compared. For example, you are saying to your friend, I drive a car for 40. So 40 means it is just a numerical number. We don't know whether it is specifying a weight or a distance or amount, anything we don't know. But if I say I drive a car for 40 kilometer per hour, which is giving a good meaning to the sentence, which means you are able to drive a car for 40 kilometer in 1 hour. So that 40 is the unknown quantity to which you are adding a unit kilometer per hour. So we are adding a new unit, that is a standard quantity with which unknown quantities are compared. And next we are going to see what are the system of units were followed in the earlier times. In the earlier times, three system of units were followed. The first is CGS system, and the next is FPS system and MKS system, and it is abbreviated as centimeter, gram and second as follows. But now we are following a new system which is SI system of units, and this is also a modernized and improvised form of the previous system, that is CGS and FPS and MKS system, and this is also accepted in almost all the countries. So this is called as international system of units. So here in international system of units we are having 7 fundamental quantities which are length, mass, time, temperature, electric current, luminous intensity and amount of substance, and its units and symbol is given here. So we are going to discuss first 4 in detail. The first one we are having is length. Length is the extent of something between two, which is from point A to point B, that is from Chennai to Trichy. So the SI unit we calculate them in meters. For a longer distance we use kilometer, but this is in the case of some measurable unit. But in order to measure very large distances, that is from the distance between sun and earth, Mars and earth, so you have to use the following units called astronomical unit, light year and parsec. So astronomical unit means it is a distance of the center of the sun from the center of the earth. Light year means it is a distance travelled by light in 1 year in vacuum, and parsec is used to measure the astronomical objects that is outside the solar system. We use parsec. Next we have is mass. Mass is the quantity of matter contained in a body, that is the amount of matter, which is present in a body. Whether it is 20 tomatoes in a carry bag will weigh one, will give some amount of weight, or and 30 kilometers of tomatoes will give you one weight. That is amount of substance, that is the quantity of matter. 20 weighs differently and 30 tomatoes will weigh differently. The SI unit is kilogram. Time is the measure of duration of events and the intervals between them. So that is from morning to evening, afternoon till night. So intervals between, from one, starting from one event to the another, and the intervals between them we call it as time. The SI unit is second. Temperature is the measure of hotness or coldness of a body, we all know very well, and its SI unit is Kelvin. Next we are going to see what are the rules and conventions for writing this SI system of units and their symbols. And first one you have to remember is the first point says is, if you are going to write the units named after the scientist, you have to use only small letter, you should not use any capital letter. So for example, if you see in the first point, Newton, Henry, Ampere and Watt are the names of the scientist. So if you want to use them directly, you have to use only starting letter as small letter, not capital letter. But if you see the second point, if you want to use only the starting letter, that is N for Newton, you should not use the small letter, you have to use a capital initial letter, that is N for Newton, H for Henry, A for Ampere and W for Watt. And third point, if the units are not derived from the proper noun, for example meter, then you have to use only small letters, M for meter and kg for kilogram. And fourth point, there should not be any full stop or punctuation after the symbol. That is, if you could see here 50 meter and not 50 meter and full stop. You have to write only 50 meter and leave it as it is. And the next point, the symbol of the units are not expressed in plural form. You have to write only 10 kg and not as 10 kgs. And if you are expressing temperature in Kelvin, you should not use the degree sign, the dot should not be used. And next, seventh point is, you have to use the solidus, that is that slash is given. No, seventh point, solidus means that is slash. For example, you can see the example there, ms power -1. So instead of this power -1, you can use that slash, but at the same time you should not use more than 1. So here you are having j slash k, that is slash, that is solidus, you are having 2 times, so you have to use only this form, joule, Kelvin inverse and mole inverse. So that method only you have to use. And next, eighth point will be, the number and units should be separated by space. There should be space. And ninth point, only accepted symbols should be used and you should not use of anything of your own. And the 10th point, the numerical values of physical quantities should be written in the scientific form, that is proper prefix should be used, that is like 10 power 4, 10 power 5, properly it should be used. And next we are moving on to the measuring mass instruments. The first one you can see here is common beam balance. This you would have seen in mostly all the grocery shops. So what they do, one side they will place the standard weight. If you want to buy 2 kg of rice, they will place the 2 kg stone on one side, on the other side they will place the rice for which comes, they will add rice on the other side, which is until they make equally balanced. So this is a common beam balance. And next one is physical balance. This is also more sensitive, so this is mostly commonly used in laboratories. And next one is we are going to see is digital balance, which is more accurate also. So here the accuracy can go up to few milligrams, that is till 10 milligrams also it can go for. So this is commonly used in mostly in jewelry shops, you can see. And next is spring balance, and this is also used for measuring more amount of weight. So you have to hang the object in that spring, so depending upon the weight of the object you can measure it on the scale readings, you can see that is spring balance. And next we are going to see the difference between mass and weight. Mass is a fundamental quantity, but weight is a derived quantity which is derived from mass, and mass has only magnitude, so it is a scalar quantity, but weight has both magnitude and direction, it is a vector quantity. Mass, it is amount of matter contained in a body, but weight is a normal force exerted by the surface on object against gravitational pull. And mass remains same everywhere, but weight varies from one place to another place. Mass, it is measured using a physical balance, but weight, it is measured using a spring balance. Unit of mass is kilogram and the unit of weight is Newton. Next we are going to see what is meant by accuracy. Accuracy refers to the closeness of a measured value. So for example, I am asking you to prepare 10 gram of sugar from sugarcane juice, but you are able to obtain only 9.5 grams, but 9.5 grams is closer to 10, yes or no? So if your value is closer to the actual value, that is if 9.5 is closer to 10 means then you are maintaining accuracy, then your value is accurate, that is it is closer to that value. But if you are able to get only 2 gram instead of 10 gram, then you are not maintaining accuracy, then that is not called as accurate. So accuracy means closeness, nearest value, we call it as accuracy. So for today you have, this is homework. There is define fundamental quantity with example and define unit and differentiate between mass and weight. You can write any 4 points, and the next class we will discuss about the measuring objects, that is vernier caliper and screw gauge. Thank you.